Okay, so for Unit 2, we're going to start out by looking at the basic algebra. We did all the calculations with numbers and stuff in the last unit. Unit 2 is algebra and measurement. We're going to look at measurement conversions here next in the next couple weeks as well. But for today, we're going to start out with something like this. How do we deal with, what this means basically is it's an equation, and all equations start out in this simple form as a variable equals a number, or a number equals a variable. To work with them, of course, the key is understanding that symbol there, which is the equal sign. Now here's a little tougher question. What does it mean? Okay, there you go. It's really hard to describe it without using the word equals, isn't it? What's on one side is equivalent to what's on the other side, or one way of thinking is what's on one side has the exact same value as what's on the other side. In fact, you can think of it as a balanced scale. What's on one side exactly balances what's on the other. And as I said, all equations start out in this form, and they're built up from there. So if I wanted to build onto this equation to make it more complicated, there are a lot of things I could do. For example, maybe we would add 5 to it. So this now becomes x plus 5. But since it's a balanced scale, if I add to one side, it's going to tip unless I do exactly the same thing to the other side. So I add 5 to the other side. 7 plus 5 is 12. So we just built a slightly more complex equation. Now, most of the time, we're not being asked to build an equation. What we're going to be asked is to solve an equation. And when you're asked to solve an equation, what it is asking you to do is to take that equation back apart. So you're going to reverse the steps. This equation was built by adding 5. To take it apart, we're going to subtract 5. Very good. So we subtract 5, and it takes that piece off, leaving us with just the x. Now, also, again, because of that balanced scale, whatever we do to one side, the scale is going to tip unless we do exactly the same thing to the other side. So we subtract 5 from the other side as well. We get 7. So x equals 7. Which is what we better get because that's what we started with. Now this one was easy to do because we built it. We watched it be built, so we knew how to take it apart. The tough part is to look at these and figure out how it was built so that we can take it apart. We might have y minus 9 equals 4. Now this one, I realize most of you can probably look at that and you have the answer already. But let's go through it step by step. We find the equal sign. And then we identify which side has the variable on it, which is over there. And then on that side of the equation, we ask ourselves, what's keeping that variable from being by itself? Right now it's the 9. So the second question is, what operation was used to build that 9 onto the variable? Well, it was subtracted. So this equation was built by subtracting 9. How are we going to take it apart? Add 9. Adding 9 gets rid of the subtracting 9, leaves us with just y. We go over to the other side here and we add 9. 4 plus 9 is 13. So 13 equals y, or y equals 13. We might have something like this. So again, if we just go through the steps, here's the equal sign. There's the side with the variable on it. What's keeping the variable from being by itself? The 7. What operation is attaching the variable? Multiplication. Good. So this equation was built by multiplying by 7, so we're going to take it apart by dividing by 7. So we have z by itself there. We divide the other side by 7. 28 divided by 7 is 4. So z equals 4. Not all of our equations are going to be that simple. We might have something like this. When we look at an equation like this, we're going to go through the same steps. We find the equal sign. We identify which side has the variable on it, which is over there. What's keeping the variable from being by itself? Well, there's two things this time. We have the 7 and the 3. Very good. Now, there's two different operations. The 3 was multiplying the variable, and then the 7 is subtracted from the variable. According to order of operations, which one would happen first? Multiplication or subtraction? Multiplication. So when this equation was built, what was done to x is it was multiplied by 3, then 7 was subtracted from it. Now, if you go, let's say you put something together, you put together a toy or piece of furniture or whatever it is. You've just finished and you've just put on the last piece. If you go to take it apart, what's going to be the first piece you take off? The last piece you put on. So the last piece put onto this was subtracting 7. The first thing we're going to take off is that by adding 7. So it gets rid of the minus 7. We're left with just 3x. Now we have to do the exact same thing to the other side. 35 plus 7 is 42. Next, we need to divide by 3. Leaves us with just x there. 42 divided by 3 is 14. Good. Any questions? Now, I don't expect you to write this out every time you solve an equation. You can learn to look at them and figure that out. What we have here is what we call two-step form. There were two things that are done to the variable. And you're just going in backwards order. The reverse order of what you would have done to put it together, or reverse order of operations if you want to call it that. So I'm not going to make you write this out, but it's there if you want to use it. It definitely does help. Also, whenever you get an answer like this, you can always double check it by just going back up to the original equation and replacing the variable with the number we got. If x equals 14, then I should be able to go back up here and say 3 times x now becomes 3 times 14 minus 7. And let's check to see if that equals 35. Well, 3 times 14 is 42, minus 7 is 35. So we get the same value on each side of the equation. We're relatively sure that that answer is correct. So let's try something like this. So again, here's our equal sign. There's the variable. This equation was built by taking the y, multiplying by 7, and then adding 2 to it. So how are we going to take it apart, or how are we going to solve it? We subtract 2. Perfect. So subtracting 2 leaves us with 7y and 28. And then we divide by 7. So 4 equals y. And again, we can come back wherever that y is and replace it with the 4. So does 30 equal, instead of 7 times y, 7 times 4 plus 2? So 7 times 4 is 28, plus 2 is 30. So yes, it is true. There's 30 on both sides of the equation. Looking at this one, what's slightly different here? Yeah, the x appears twice. If we look at this, if we go to break it down, we find the equal sign, and we identify which side the variable's on, and we find that there's x appears twice on that left side. Now, since it's on the same side, if we keep thinking about that balanced equation, is it possible to just take those two x's and push them together to make one big pile? Would that affect how the equation balances? No, it wouldn't. So we can go ahead and just put them together. 2x and 3x make 5x. Now we still have the minus 3, and that still equals 52. So now what would we do to start solving this? Add 3. So it leaves us with just 5x. 52 plus 3 is 55, and then divide by 5. So x equals 11. And once again, we could go back and double check. We could put 11 in here for x. So instead of 2x, it's 2 times 11 minus 3 plus, instead of 3x, it's 3 times 11 equals 52. 2 times 11 is 22 minus 3. 3 times 11 is 33. 22 minus 3 is 19, plus 33 is 52. Questions? Okay, when we start with this one, what do we notice? Exactly. We find the equal sign, we go to identify where the variable is, and the x appears on each side. Now we can't just push these together in one big pile anymore because they're on opposite sides. So we're going to need to just get rid of one. And normally we get rid of the smaller one because it's the easier one to get rid of. And mathematically, the way we do that, really what we're thinking about doing is grabbing it and pulling it off and throwing it away. Mathematically, how we do that is we subtract it. So there's a 2x there. We're going to take away 2x or subtract 2x. That leaves us with just 17. But we still have to think of this as a balanced scale. If we took 2x off of one side, we need to take 2x off the other side. Perfect. We can't subtract 2x from 4. We can only subtract things that have the same name, like we looked at a few weeks ago. So we have to take the 2x away from the 5x. That'll give us 3x minus 4. Now this is in a familiar form for us to solve. What are we going to do? Okay, we add 4. Perfect. So 21 equals 3x, and then we divide by 3. So 7 equals x. And by this point, I hope you're catching on that you can put that back in there and test it to make sure it works. I'm going to leave it up to you guys to do that from now on. Okay, so looking at this one, what needs to be done? Well, this one has both of them. Okay, perfect. Yeah, this has both cases. The x appears multiple times. It appears twice on one side and then once on the other. And when you have something like that, you need to deal with each side of the equation first. See if you can simplify anything on each side before we start swapping anything back and forth. So on this one, on the left side over here, we have 5x and 2x, which make 7x. Now we can't forget the minus 7. So this becomes 7x minus 7, and the other side has not changed. It's still 3x plus 21. But now we still have that x appearing more than once, and we need to take care of that. So which x are we going to get rid of? The smaller one, which is 3x. And we're going to get rid of it by subtracting 3x. So it leaves us, leaves us with 21 over here. Subtract 3x on the other side. 7x minus 3x is 4x. We still have the minus 7. And then, what will we do? Add 7. Perfect. So 4x equals 28. And then we do divide by 4. X equals 7. Any questions? So here, in this one, what sticks out at us? The parentheses, good. Whenever we see a parentheses, it should scream at us, do something here first. Now, in this case, we look inside the parentheses. Is there anything we can do there? No. Well, we have 4x or 7x and minus 5. We cannot combine those because they have different names. One has the name of x, and the other one is just 5 1s. We can't combine those. So at this point, there's nothing we can do inside the parentheses. The second question is there anything that needs to be done to the parentheses? Yes, sir. Perfect. It's being multiplied by 4. Now, to do that, there's a couple of different ways we can do it. The brute force way, or the long way of multiplying that out, is just like multiplying numbers. You have 7x minus 5 times 4. Well, you do 4 times the negative 5 is negative 20. 4 times 7x is 28x. So that's the actual long way of multiplying out these numbers. Now, most of us were taught something called distributing, which all this is a way of shortening that up. You're doing it kind of backwards. You're going to start with the 4, and you're going to go 4 times 7x is 28x. And 4 times negative 5 is negative 20. And that equals 36. Now what? Add 20. Perfect. So 28x equals 56. And then we will divide by 28. So x equals 2. So tell me what to do on this one. Perfect. Distribute the 3. So 3 times 5x is 15x. 3 times 1 is 3. It's a positive 3, so I put a plus there. So 15x plus 3. Then what? Subtract 3. Perfect. So 75 equals 15x. And then we do divide by 15. So 5 equals x. Well, let's find one that's a little bit more complex. We're out of paper. I said just a little more complex, right? Bless you. Okay, so let's take a look at this one. See what happens. Now this one looks like a monster, I admit that, but it's not so bad. Remember, the first thing is always find the equal sign. And in a problem like this, we can deal with each side of the equal sign separately while we reduce things down and combine things. So on the left side over here, we see the parentheses, so we have to start there. Is there anything to do inside that set of parentheses? No, but there is something to do to it. It's times 2. So 2 times 3x, 6x. Now this isn't 2 times 7, it's 2 times a negative 7, which would be negative 14. So it's minus 14. Now we still have plus 3x and minus 1 here. And we're going to keep combining. We have 6x and 3x make 9x. Negative 14 and negative 1, negative 15. So we're done on the left side of the equation. On the right side, we see parentheses. Since there's more than one set, we start by working left to right. So the leftmost one here, we're going to distribute 5 times 2x, 10x. 5 times Negative 4 is negative 20. And then this one is 2 times 3x is 6x. Now, since there's something in front of it, we have to put a plus 6x. 2 times 1 is 2. And the negative 6x minus 2. Now we can combine. We have 10x, 6x, and negative 6x make 10x. Negative 20, positive 2, and negative 2 makes negative 20. Now what? Perfect. Okay, so since we have an x on each side, we have to get rid of one of them. The 9x is the smaller one, so we're going to take away the 9x. It's gone. We're left with a negative 15 here. We take away 9x from the other side. Well, 10 minus 9 is 1, so it's 1x or just x. Kind of like 1 inch. 1 inch or just an inch is the same thing. Then we have negative 20. What are we going to do next? Add 20. So negative 15 plus 20 is a positive 5 equals x. Now on one like this, I would almost always go back and put that 5 in where the x is. So I'd replace each of these x's with 5. And make sure I get the same value on each side of the equation. Okay, well, enough of that. The next step, the reason why we're solving equations. Well, there are a couple of them. There are going to be a couple of formulas you guys are going to know that you may have to solve in the future. But the big application for now is going to be dealing with mixture problems. And to understand mixture problems, I'm going to talk a little bit about solutions. In a solution, there are two parts. There's a solute and a solvent. The solvent is the main part of the solution. Normally, it is a liquid. Not always, by the way. There are gaseous solvents and there are solid solvents. But in the medical field, it is almost always a liquid. The solute is then what gets dissolved into that solvent. So if you think of salt water, that's a solution. In salt water, the solute is the salt because it's what disappears into the water. And the water is the solvent because it is the main part of the substance. It's what stays visible in the solution. You guys have a good weekend. I'll see you next week. All done? Thanks. So again, that solvent, that's the part that stays visible. The solute is what disappears into the other substance. Now, and of course, there are all sorts of solutions. Salt water. Many of your medicines are dissolved into water. In fact, for us, what we're going to use is a kind of a universal solvent is going to be labeled NS. NS stands for a couple of different things. It can be referred to as neutral solution. By neutral solution, all it means is a solution with absolutely no medicinal value. It's like sterile water or whatever. Or normal saline, which has the same meaning. Normal saline is just sterile water that is pH balanced to the human body, so it has the same pH as the human body. So it has a slight amount of salt added to it to pH balance it. So anyway, mathematically, in a solution, the amount of the solute can be found by taking the amount of the whole solution times the concentration. Concentration is a percent, usually written as a decimal. For example, let's say that we have 400 milliliters of an 8% salt water solution. Now, a lot of times that'd be written as a salt in water solution would be the technical way of writing it, but we know what we mean when we say salt water. So the amount of salt is 8% is 0.08 times 400 milliliters. That would be approximately 32 milliliters of salt. Now here's the tricky thing. Does that mean that there's 400 minus 32? Or 368 milliliters of water in that solution? No, it doesn't. When you're mixing a solution, the total volume is not equal to the sum of the two ingredients. What will happen is you have your particles of water. Since water is a liquid, the particles are very loosely bonded, which means there's actually gaps between the particles. The reason the salt can dissolve or hide in the water is because the salt particles are small enough that they can fit in those gaps between the water particles. They actually fit into those gaps and they hide there. You can't just keep putting more and more salt into the water and keep it dissolving. Eventually it fills up all those gaps and then no more salt will dissolve. It falls to the bottom. So because there are those little gaps that the salt hides in, it doesn't add a whole lot to the volume of the salt water. So when we're looking at this, the total volume is 400, but the two volumes are not additive like that. So anyway, with that in mind, that we can find the amount of the solute by multiplying the percent concentration by the total amount of the solution, now we can start looking at mixing solutions. Let's say that we mix 400 milliliters of 12% solution, and it doesn't really matter what the solution is, whether it's a medication in neutral solution or what it is, as long as the two solutions we have are the same type of solution. So let's say we're going to mix a 400 milliliters of 12% solution with 600 milliliters of 18% solution. Find the concentration of the final amount here. Well, what we have here, what we're tracking here is the amount of the solute, the salt, the medication, whatever it is that's being dissolved. So if we look at the first solution here, the amount of solute in that one is 12%, so 0.12 times 400 milliliters. In the second solution, the amount of solute, the medication or whatever, is 18%, so 0.18 times a total volume of 600 milliliters. And what we want to know is what is the concentration, we're going to call that C, of the final solution. Well, how much of that final solution do we have? Well, we're adding 400 milliliters to 600 milliliters. We better have a total of 1,000 milliliters. So we can now find the concentration of this final solution. 0.12 times 400 is 48. 0.18 times 600 is it's 108, isn't it? 108 equals C times 1,000. We're going to add 48 plus 108, 156. equals still c times 1,000. What are we going to do to solve this for c? Well, c has been multiplied by 1,000, so to solve it, we divide by 1,000. So it's 0.156 equals c. 0.156 is 15.6%. So when we combine those two solutions, we get a final solution that is 15.6%. Now, normally, we don't just randomly mix two solutions together and figure out what the final concentration is. Generally, we have a concentration that we want to find. We need a certain level. So let's say that we have 38% and 50% solutions. And we need a 46% solution. So my question is, how much 50% do you need to mix with 240 milliliters of 38% to get the desired 46%? So it's still the same formula we used in the last one, only it's going to be a little bit trickier to put together. What are we mixing here? What 2% are we mixing? We have 38% and 50%, and we're mixing them to get 46%. Now, just like before, we're going to track the amount of solute. Do we know the number? And each, the amount of the solute comes from the concentration times the total amount of that solution. We have 38%, which is 0.38. Do we know how much of that solution there is? Yeah, 240 milliliters. 50% we know is 0.5 or 0.50. Do we know how much of that solution there is? No, it says how much of the 50%. That's what we're trying to find. So that's going to be our x. Now for the 46%, it is 0.46. Do we know how much of that we're going to have? Well, not really. But we can describe it from the other ones because the amount we're going to have is going to be the amount of the 38% plus the amount of 50%. So 240 plus x, or x plus 240, whichever way you prefer to put it. That's the total amount of solution. What this is basically saying is, whatever the solute is, however much we had to start with, we better have that same amount after we mix them. So now, we have 0.38 times 240 is 91.2. 0.5 times x is just 0.5x. 0.46 on the other side there times 240. It's 110.4. And 0.46 times x is 0.46x. Anybody have any questions on what I just did to get from here down to here? Okay. So now that we're down here, we have an x on each side. We're going to get rid of one. Which one are we going to get rid of? Smaller one, the 0.46. So that's gone. So 0.5 minus 0.46 is 0.04x. Now it looks complicated because there's decimals in it, but it's the same as any of our other two-step equations. What do we do first? Perfect. We subtract 91.2. This will be 0.04x equals 19.2. And then divide by 0.04. X equals 19.2 divided by 0.04, 480. All of our other measurements were in milliliters, so that'll be in milliliters as well. So 480 milliliters is how much we need. Does that make sense? Okay, it'll only make sense. This is one of those things you got to see a lot of examples. You're going to have to try some examples to make it work. So we'll get through one or two more examples here before the end of class, and then I'll give you some to try in your homework. Let's say that we have on hand 4% and 28% solutions. We need 24% solution. My question is, how much 4% to mix with 360 milliliters of the 28% in order to get that desired 24%? So again, let's map it out step by step. What are the 2% that we are mixing? 4% and 28%. And we're hoping to get 24%. So we're starting out, how much of the solute is in the 4%? Well, it's 0.04 times, do we know how much of it we have? No, that's what we're looking for. How much 4%? So that's going to be X. Plus, for the 28% is 0.28 times, do we know how much of that we have? $360 milliliters. Good. And that's going to equal, that's 24%, it's going to be 0.24. Do we know how much of that we're going to have? 360 plus X or X plus 360, either way. So now we can start simplifying. 0.04 times X is just 0.04X. 0.28 times 360, 100.8, equals 0.24 times X is 0.24X, and 0.24 times 360. $86.4, so plus 86.4. Then what? Well, the variable appears twice. Do we just push it together and add them together? Exactly. There's one on each side, so we have to get rid of one, and we're going to subtract the smaller one, which is the 0.04x. So we're left with 100.8 minus 0.04x over here gives us 0.2x plus 86.4. And then we subtract 86.4. 0.2x. Yeah, 14.4. And then divide by 0.2. Which is what? 72 exactly, yeah. So it's 72 milliliters of X was the amount of the 4%. So you need 72 milliliters of the 4%. What do y'all think? Think it's something you can try on your own? Okay. In your book, it's going to be pages 53 to 54. 1 through 15. If you want to just do the odds, you can. That's the mixing problems. Now, we will start out next week talking about those more. So if you struggle with them at all, don't worry. We're going to do more of them next week. Then also, back on page 49 through 50, 1 through 43, the odds. That's the solving equations, just the generic equations. And that's it for the week. 3 weeks from today, by the way, is scheduled to be our next unit test, just so you know. So we'll have 2 more weeks of lecture, and then we'll have our next unit test.